we're back for installation number 3 of the 10 magnet rotor with the 5 drive coils. As you can see, the motor's running already, and I wanted to go on record before I actually started it to predict what was going to happen, which was slower motor speed and much less current. And it seems to me like 17.6, they're going to put that on a finer scale, 17.3, 4, 5, let's call it 6. If I doubled that, let's just say 18 times 2 is 36 milliamps. So we wired the thing in full bifilar mode and got like slightly less than half the speed with no helper magnets, of course, and not quite less than half the current draw. So it seems and the voltage, of course, there you can see that 13. Seems to me that this whole bifilar business isn't as good as I thought it would be. However, there are still a number of things we can do. One of the things I was planning on doing is turning these coils sideways to have the magnets draw to the flat side here, as opposed to the open hole side. That's going to involve me cutting up some new pieces of wood here, and excuse me, I'm sorry. Yeah, doing that, so, and drilling some holes in them and all that crap. What I'd like to do is, I do have another piece of plexiglass. I'm going to make another base. I'm going to make 2 motors. I just hope I can find another VCR head that's almost identical, if not identical to this one, but I kind of doubt I'm going to find that. I've got 3 or 4 other VCR heads here, but they're heavier, more weight to them, which might, I don't know, might be a benefit, you know, kind of a heavier flywheel effect, maybe, I don't know. Anyways, let's see what happens when we put some helper magnets on here. We're still, so yeah, well, I guess I'll give you a RPM reading here. Switch over to the other hand here, get the RPM thingamajig going, and you can see it's just under 800, 796. You can see that or not? There you go. Yeah, okay. Alright, so let's get some helper magnets on there and see what happens. Helper magnet number 1. There we go. You can hear that speed up. And we're going to have to switch our current meter over to a higher setting here. So we've gone up, like 1 milliamp. Helper magnet number 2. Alright, milliamps gone up another milliamp. Helper magnet number 3. Helper magnet number 4. Up substantially, but she'll come down. Helper magnet number 5 really is useless right here. It actually works I'm just going to let it sit on top for now until I get that block cut down. Anyways, we're looking at 25 milliamps. 25 milliamps. The voltage pretty much stayed pretty much at 13 there. And we're going to look and see how much speed we gained here. Oh, come on, stay on there. I'd say 800 times 2 is 1600, so we more than doubled the speed. And if we give it some time to stabilize, adjust itself, it might get closer to 1800. So we don't quite get what used to happen in the past is at least a multiplication of 3, a factor of 3 for speed increase, and current going down rather than up. But nonetheless, we still have, sorry about that, we still have a fairly decent power consumption here at, we've got 0.0, let's call it 0.0258 times 13.0.06, and that gives us 336.9, let's just call it 337 milliwatts. So we're getting close to 1800 RPM for 380 milliwatts. Is that what I said? No, somewhere's in there. Yeah, so that's video number 3. We're still getting about 55 volts out of the steering diode and that capacitor. Actually, it's about 58 volts, 58.43. So, but unfortunately, once you put a load on that, it just completely dies. So there isn't a whole lot of anything there worth talking about. So yeah, I think that's it for now. I think we're going to go back to, or possibly instead of going back, we'll create some new blocks to hold the coils and try the horizontal approach here and see what happens with that. So that might probably more than likely be the next video. Signing off for now.